with one more thing. Before we do that, we'll need a requisite knowledge of binomial theorem, how to expand binomial theorem. But because if you don't learn it, I'm going to lose you somewhere. So how does binomial theorem works? Let's assume we have stuff like x plus y raised to the power of 3, and then we are asked to expand this. By expanding, it's going to give us a lot of problem, because by doing that, naturally we're going to do x plus y, and then what, x plus y, and then what, times x plus y into 3 places, right? And then we start expanding these two. Well, let's expand these two. We're doing that, we have x plus y, this one we stand by. Expanding that, we're going to have x times x, and then x times y, and later we'll come and do y times x and y times y. That's how to expand, right? So in doing that, we have x times x giving us x squared plus x times y giving us what, xy, right? And then plus y times x giving us yx, that's y times x, and then y times y giving us what, y squared, right? Let's try and expand. In doing that, we're going to have for the first one we have our x plus y, but the other one there we have x squared plus x plus y plus x plus y gives us what, 2xy plus y squared, right? And then what do? We start using this to expand the bracket. So by doing that, x will multiply x squared, x will multiply 2xy, and x will multiply y squared. The same thing, y will multiply x squared, y will multiply 2xy, and y will multiply y squared. So let's get on to that. By doing that, our answers becomes x times x squared, we have x cubed, plus what, x times 2xy, we have 2x squared y, plus what, x times what, y squared, we have xy squared. That's for x multiples. Let's look at y multiples. Y times x squared, we have x squared y, and then plus y times 2xy, we have 2x y squared, and then y times y squared, we have y cubed, right? That's that for that. So let's try and collect like terms. We have 2xy plus what, 2x squared y plus x squared y, right? So in doing that, we're going to have x cubed plus what, 2x squared y plus x squared y, and then plus 2xy squared plus xy squared, that's plus this, and then plus what, y cubed, right? By way of expanding this, I believe we're going to get x cubed plus what, 2x squared y plus x squared y gives us what, 3x squared y, and then plus 2xy squared plus xy squared gives us what, 3xy squared, right? Plus what, y cubed, then y cubed. So this becomes the answer, the total overall answer for this expansion. You see how long this gets, right? But there is a simple formula we can use, a binomial formula we can use, a theorem we can use. How do we do that? Here's how it works. If we have stuff like x plus y, let's assume that our power is power n. What we do is simply start by combinatorial analysis. That's by saying n combination 0, it starts with 0, put our x and put n minus 0 as its power, right? And then put y raised to the power of 0. Simple. Start with n combination 0, our x carries n minus 0, and then our y carries 0. It moves on. Now this 0 will start increasing, start going in the increasing order. So next will be what? N combination 1, x what? N minus 1, and then what? Y raised to power 1. You see how I got? So, and from there we're going to have n combination 2, then what? X what? Xn minus 2, y raised to power 2, right? And that's how it's going to continue. This is the first one, and this is the second one, and this is the third one. It's going to continue like that. With that, we have n combination 3, have xn minus 3, and y raised to power 3, plus so and so forth. That's how it increase. So let's try and apply this strategy for this to see how it works now. So for that, we're going to have stuff like x plus y raised to power 3 using our strategy is going to start with what? 3 combination 0, right? And then we have x raised to power 3 minus 0, y raised to power 0, plus what? Plus 3 combination 1. Then we have x raised to power 3 minus 1, y raised to power 1. I've taught you this now, very easy. Next, we're going to have what? 3 combination 2, and then we have x3 minus 2, y raised to power 2. Further on, we have plus 3 combination 3, and now the same. And I have x3 minus 3, y raised to power what? 3. Let's start with this now. I haven't done this strategy. Let's start with this. How does combination work? So if in combination we have stuff like 3 combination 1, how do we expand this? It is 3 factorial over 3 minus 1 factorial, 1 factorial. What does 3 factorial means? We reduce it. 3 factorial simply means 3 times 2 times 1. And then 2 minus 1 gives us 2 factorial, 1 factorial. Right? So let's just, I'll show you as we get on with this. The answer to this simply becomes 3 factorial over what? 3 minus 0 or factorial, 0 factorial. X, 3 minus 0 is 3. Y raised to power of 0 is what? Is 1. And then 1 times that is all the same thing. So we're done with the first one. Alright? Alright, let's go to the next. Plus what? 3 combination 1. We have 3 factorial over what? 3 minus 1 factorial, 1 factorial. Right? And then we have x. 3 minus 1 is 2. Y raised to power of 1 is 1. Right? Why did I not put this? Because anything raised to power of 0 is 1. 1 times the thing will give us the number. So we're done with the next one. So this is the plus. This is our second one. And then the third, what do we have? We have 3 factorial over what? 3 minus 2 factorial, 2 factorial. Right? And then we have our x. 3 minus 1 is 1. Y, that's raised to power 2. So we're done with this one. It's our plus. Right? This is the next one. And then the last but not the least, we have what? 3 factorial, 3 minus 3 factorial, 3 factorial. Right? Let's go with that. We're going to have what? X. 3 minus 3 is 0, y raised to the power 3. Of course, you know, 0 raised to the power of 0, anything x raised to the power of 0 is 1. Any number raised to the power of 0 should be 1, right? So x raised to the power of 0 is 1. 1 times everything will give us everything. That means this 0 is gone. This x is gone. If we try and expand, you see how easy it is. Very easy. So with this, we're going to have 3 factorial over 3 minus 0 factorial will give us 3 factorials. And then 0 factorial is 1. The same thing. That means 3 factorial, we cancel that 3 factorial. We are left with what? X raised to the power of 3. X raised to the power of 3. Plus, for this, we're going to have what? 3 factorial over what? 3 minus 1 is 2 factorial. Right? And 1 factorial is 1 factorial. And then we have x raised to the power 2, y raised to the power 1. Plus what? Let's continue with this. We have 3 factorial minus 3 minus 2 is 1 factorial, 2 factorial. And then we have x, y squared. And then plus what? Plus we have 3 factorial minus 3 minus 3 is 0 factorial. And then we have 3 factorial. And then we are left with what? Y cubed. Haven't understood this, I'm going to take this part of the board off and then transfer our answer to the up, and then we try and compare if we are going to arrive at this answer. So just give me a moment, guys. Alright, so let's continue. So we're left with what? We're left with this and this are gone, right? 3 factorial and 3 factorial are gone. We're left with x cubed here. X raised to the power 3, and then we have plus what? 3 factorial over 2 factorial. Now look at, if we have stuff like 3 factorial over 2 factorial, we can reduce this by saying 3 times 2 times 1. Or if we don't want to get to 1, we can just end at 2 factorial, because 2 factorial will give us 2 times 1 over 2 factorial. Why? So that 2 factorial can take off 2 factorial, we're left with 3. So in other sense, if we have stuff like 4 factorial over 2 factorial, we can reduce the upper one, the bigger one, to what? 4 times 3 times 2 factorial over 2 factorial. That way 2 and 2 factorial can cancel out, so that our answer can be what? 3 times 4, which is 12. Are you getting it now? So whenever we have a bigger one, we can reduce it to the number of this. So if we have stuff like 6 factorial over 3 factorial, all we need to do is to reduce this till we get to 3 factorial as 6 times 5 times 4 times 3 factorial over 3 factorial. Now with 3 and 3 factorial can go, and then we can get the answers to that, right? With that, so we have our x cubed plus 3 factorial times 2 factorial over 2 factorial, right? So that 2 factorial can cancel that 2 factorial. We're left with x squared y. So we have x squared y here. Let's continue. Plus what? Plus we have 3 factorial over 1 and 2 factorial. So we have 3 factorial over 2 factorial, right? 2 times 1 gives us 2 factorial, the same thing. So we can reduce this to 3 times 2 factorial. So this and this can cancel out. We now have our x y squared, right? Let's continue. We have plus what? Plus 3 factorial over 3 factorial. There's a 0 factorial here, it's 1. It's the same thing, it's not hard. So if we have 3 and 3 factorial, they will cancel out, right? They're gone. Left with what? Y cubed. In total, answer becomes what? X cubed plus what? 3x x squared y. That's 3x squared y. 3x squared y plus what? 3xy squared. 3xy squared plus what? Y cubed. Y cubed. So let's compare the answers. We discover that this answer, the answer to this, we have our 3 here. The answer to this is equal to this answer. Let's compare. X cubed, 3x squared y, 3x squared y, 3xy squared, 3xy squared, and y cubed. It therefore means that if we follow this simple principle, if we follow this simple formula, that's this one, if we follow it, right, carefully, if we follow this, we are going to arrive at the same answer than expanding it. So the reason for this is because if we have larger number like, let's assume we have x plus y raised to power 6, we want to be expanding it and then trying to solve rather than using this formula. Right, so now we understand how this works. Try and practice it. In the next video, I'm going to be applying this to proving that value. I'll see you in the next video, guys. Thank you.